All right, so the next thing we're going to do is start drawing some circles based on the points that define the shape of the dodecagon. So we're going to draw two circles, one with the radius of 1.1 and the other with the radius of the square root of 1.41. We just determined that hypotenuse of that triangle previously, so we're just going to go over here, and 1.1 squared is 1.21. So 1.1 is the square root of 1.21. Here's 1.41. So we're just going to figure out the area of that ring that we've just defined. Pi r squared, it's going to be units of pi. So 1.41 pi, subtract from that 1.21 pi, we get an area of 0.2 pi. So nice, simple, precise amount of pi. So the midpoint radius. So we're going to now calculate if we were to draw a circle based on this point right here, what's the radius of that circle? So 0.96 squared is 0.763. So the square root of that times the square root of 2, the square root of 1.306. So 1.21, 1.31, 1.41, but not 1.31, 1.306. Remembering that when you see a 6 at the end, that's a half. Okay, so we're just going to look at that a little bit more closely. That circle, when we draw it, divides that distance or that area of 0.2 pi in half. So we then have two rings. What's the area of each half that adds up to 0.2 pi? Okay, so we can find the area of those two halves of the whole ring quite easily simply by subtracting one ring from the other. So 1.41 pi subtracting 1.306 pi gives us an answer of 0.106 pi. So that's the area of the outer half of the ring. And then 1.306 pi subtracting from that 1.21 pi gives us an answer of 0.0L6 pi. Remembering L, 1, 2, 3, 4, 5, 6, 7, 8, 9, dec, L, do. So that's the area of the inner half of the two halves of that ring. So when we subtract 0.0L6 from 0.106, we get a difference of 0.01 pi. So the two halves of the 0.2 pi area circle, the outer half is 0.01 pi larger than the inner half. So that really shows how perfectly centered between the outside ring and the inside ring this point here is. So this point and this line is going to again be the radius and diameter of the circles. This is the main length that we're going to be using to create all the circles in our diagram for 360 degrees. This is the main point. Again, we're building our diagram and our circles all in units of square root of 2. So just remember, really reiterate, this length of 0.96 root 2 is foundational. We're going to be using it a lot coming up. And this length of 0.5 root 2. Here's the question: what's the perimeter of the entire dodecagon? Well, I'll just do that over here. We have 0.5 root 2 times a dozen in base 12. So again, 5 root 2, which we already discovered is the same as the square root of 4 do 2. Okay, so that's a big deal number. Square root of 4 do 2 is the perimeter of the first ring of the dodecagon. So now we're going to move from the first ring to the fourth ring, and we're going to go through the process of dividing the diameter of the fourth ring of the dodecagon into its perimeter. You can see we've already started here. We've created a circle. We're going to divide that diameter into sections of 0.96, and we're going to make those the diameter of circles. So we have a circle here with the diameter of 0.96, and we're placing it on the perimeter of the dodecagon. And we're doing so in such a way we're traveling from this point along the distance of 0.5 root 2, so one section of the dodecagon. We're putting our compass there, and we're drawing this circle with a radius of 0.49 root 2. Remember, 0.49 is half of 0.96. So when we do that, let's just take a pause. I'm going to rewrite my board. Okay, so just saying all that one more time. We start here, we travel along the distance of 0.5 root 2 along the perimeter of the dodecagon, and then we draw a circle with the radius of 0.49 root 2. So subtracting 0.49 from 0.5, we get a distance of 0.03 root 2. So that's the distance along this line between the circumference of this circle and the 45-degree line. And it's also the distance on the other side. The same thing's happening, another distance of 0.5 to the end of that section of dodecagon perimeter. So there's a gap here of 0.03 root 2 between, again, the circumference and that line right there. So just to make sure that all lines up in our mind, 2 times these two gaps, 0.03 root 2, gives us a length of 0.06 root 2. The total diameter of this circle is 0.96 root 2, so 0.96 plus 0.06 gives us a length of 0.dec. So 2 times 0.5 is 0.dec. So just saying basically that length from here to there is the length of 0.dec root 2, and it's now made up of the diameter of this circle plus these two little sections of 0.03 root 2. Okay, so the next thing that we do is the same process on the other side of the 45-degree line. We go along the distance of 0.5 root 2, draw a circle with the radius of 0.49 root 2. So it's going to be, kind of coming in something like that. It's going to have the same distance of 0.03 to our 45-degree line. So the distance between these two circles, this distance right here, is going to be, again, 2 times 0.03, so 0.06 root 2. So again, the gap between these two circles, or the distance between the circumferences of these two circles, is going to be 0.06 root 2. So then we do that same process on the other 4 corners of the dodecagon, where everything's exactly the same. We have a perpendicular line of the dodecagon to the 45-degree line, or the equivalent line on the other side. So if we look at this diameter, we can see that we have 1, 2, 3, 4 sections of 0.96 root 2. Then on the other side of the 0.00, we're going to have 4 more sections. So that's 8 in total. So again, 2, 4, 6, 8. We've divided the diameter of the dodecagon into its perimeter once. We want to do that now 2 more times. We want to put 2 more of these circles in this section and 2 more on the other section between here and the y-axis and here and the x-axis. So what we're going to do is, to begin that process, is draw 2 larger circles. We're going to do one circle that's defined by this point here. So it's going to have a radius of 4 times 0.96 root 2. And then we're going to draw a circle that has this defined by this point, which is going to have the radius of 0.49 root 6, 0.96 root 2 times 4 plus 0.5 root 2 at a 90-degree angle. So that's what we're going to do to find out that radius. We're going to draw these circles, and then we're going to anchor the circles here on this same circle, but we need to locate the 15-degree line so that we can place these circles on either side of the 15-degree line in the same way that these 2 circles are placed on either side of the 45-degree line. So how are we going to do that? All right, that's the end of the second video in the series. You can now proceed to part 3.